It's time for another amazing chemistry video with Mr. Stapleton. Proudly sponsored by Farmers Really Nice Coffee.
Hi guys, welcome to the next video. This is 3.8 in the organic. There's only 3 left in this one, so this one's reasonably short, so it shouldn't be too complex hopefully, because it just combines basically some chemistry we looked at in the carboxylic acid and amines and brings them together to make amides. Now penicillin here was one of the very first drugs invented. Was really useful in terms of combating bacterial infections, and made a massive change in terms of life expectancy and ability to combat common sicknesses that people had. And penicillin actually has a couple of amide groups in it. So there's actually one here, and there's another one here as well. So the amide group is where you have a nitrogen from an amine attached to a carbonyl group, which comes from a carboxylic acid. So the actual amide group, if I get a drawing pen out here, okay, the actual amide group, let me go to that colour, all right, is this bit here. Okay, so it's the nitrogen with the carbon and oxygen on it there. That's your amide. Now, quite often this can actually be a hydrogen through here, which is what you see quite often. So, but not always. Over here in acid amide, okay, we've got here's our amide group here, okay, and we happen to have 2 hydrogens on it. Here in caffeine, which you'll find from quite possibly the best drink ever. This was from the Father's Day one in 2017. They had all these different Farmers Union iced coffee options that you could get. Caffeine has a couple of amide groups in it. So there's actually one here, okay, and then there's another amide group through here as well. Okay, this is an amine, and that's an amine as well. Okay, so excuse me for a sec. Okay, so to make an amide, as we've said, we do a condensation reaction between a carboxylic acid and an amine. Now, it can be a primary, secondary, or tertiary amine. It doesn't really matter, and it's kind of exactly the same as we looked at with the ester formation. So here you can see we've got a carboxylic acid here, and down this end we've got amine here, and we eliminate our water over here, okay, to form our amide group. Okay, which you can see over here. So there is another video on amide formation as well, which I suggest you have a look at. But realistically, it's pretty straightforward. All you do is you draw them next to each other. All right, eliminate out the OH on one, take a hydrogen off the amine, and then just link the nitrogen and the carbon together to get your amide group. It's pretty straightforward. Like an ester formation, you can also go backwards because we're doing a condensation reaction. So what you can do is actually add water back into the reaction. So this H plus here means that we're doing it under acid conditions here. And when we do acid hydrolysis, because we've got an amine, which is a base, we protonate the amine and we get our acid back. Whereas if we do it under alkaline hydrolysis, we deprotonate the carboxylic acid and just get our normal amine. So what they might ask you in the exam, or probably more than likely, is they'll give you an amide. They'll talk about doing hydrolysis of it, and they'll say draw the structure of the product under either alkaline or acid hydrolysis. They'll ask one of the two. So just make sure you, from the amine section, remember that the amine can get protonated, and that's really important in terms of biological chemistry because that makes it water soluble due to iron dipole interactions. Or you can deprotonate the carboxylic acid under alkaline conditions, which again allows you to form, say, a sodium or potassium salt, which again allows it to be water soluble. So it's quite useful in terms of splitting up the amide. So I've got just a bit of a couple of questions here for you. I've got 3 amides here, just asking you to see if you can write the structures for the amine and carboxylic acid that's formed from these amides. You could try doing it under both alkaline and acid hydrolysis, and seeing if you can get the right answers as well. So you might want to pause it and just try and do those. Okay, but hopefully it's fairly easy. What I'm going to do now is just show you on the first one. So here, actually I'm going to show you on this third one here, which is the most complex one. So to do your hydrolysis, what you want to do is break this amide bond that you got here between the carbon and the nitrogen. Okay, then you're going to put your water back in. So you can end up with your CH3, CH2, and then your carboxylic acid functional group here. Again, sorry, I'm drawing with the mouse, which makes it a little bit harder. Okay, so that's from this bit down here, that was the carboxylic acid, and then the amine we had over here, we had nitrogen, CH3, there was a CH3 there as well, and we're trying to keep the trigonal trigonal period arrangement around the nitrogen, so there's a hydrogen down there as well. Okay, and then if we were doing this under acid hydrolysis, I'll just change colours here. Under acid hydrolysis here, we would protonate the amine there because that's a base. Okay, and if we were doing it under alkaline hydrolysis, we would get the carboxylate ion here because the alkali would react with the carboxylic acid to form the carboxylate ion. So make sure you can draw those from each of these. This is a prac I often do with my Year 12s. This is a polyurethane, which is an expanding foam. So this starts from 10 mils of two different monomers, and it's a polymerization reaction to form a polyamide or polyurethane. It's used in marine boats. It's really, really lightweight, but really, really strong as well, and it's used to plug holes and gaps. So polyamides are something that we also covered in the last topic as well, when we looked at polyesters and we looked at polyamides as well in topic 4. So again, it's just using a carboxylic acid and amine, but instead of just having one functional group on each molecule, we have two. Okay, and we're going to go through this in a lot more depth when we go to the final topic 3.10 when we're looking at proteins. So we'll go through more depth there, but basically you can see what we've got is the carboxylic acid group here and the amine group here. We eliminate out a water molecule, alright, to form the amide group here, and then the carboxylic acid on the end, which is this one, alright, and the amine on the end, which is this one. They can react further to again form more polymers, and you get a long polymer chain. Alright, there is a video here, okay, which I've done on polyamides that you can have a look at as well if you want a little bit more help around some advice on when you get your two monomers, how you draw the polyamide that comes from it, or how you take your polyamide and you hydrolyze it back to your monomers, which they're going to ask you to do in both ways. So that's the end of the amide topic. Again, hopefully this has been fairly straightforward for you, and as always, if you've got any questions, just ask. Thanks, guys.